Evening, guys, and welcome to tonight's Drayton live training, the last one of 2023. So let's make this a good one. And it's going to be just a bit of a round, a bit of a mashup of all the stuff we've done over the last year, which doesn't actually feel like we've done a year. I'm quite surprised that it's actually, we're breaking up for Christmas again, but we are. So I'll take you through some stuff that we've looked at. And also, if you want to get any questions in. So a few questions came in on my promo video this morning. So I'll deal with them, and I've got some stuff that some prep stuff that we can look at. But any questions that you want to ask, this next half an hour is your perfect opportunity to get your questions answered. So we'll kick it straight off, and I'll begin with the first question. And this is probably this question is probably the one that's been asked the most often this year. Is can you take us through? So the question is can you run through how to recommission the 𝗿𝗿liche𝗳𝗲𝗀 when it's lost pairing to its receiver? So we're going to be looking at this one here. This are the 𝗿𝗿 receiver, the 𝗿𝗿SCR. In fact, if I bring it on the top-down camera, you'll be able to see this slightly better. So this SCR pairing with our 𝗿𝗿dige𝗳𝗲. Now, it is fair to say that this is now been obsolete and has been superseded by the new 𝗿𝗿dige𝗳𝗲. But there are lots of these out there, so it's a worthwhile thing to cover off. You can also, if you want to, you can pair the new 𝗿𝗿dige𝗳𝗲, this one here, to the 𝗿𝗿 receiver. So if you've got some reason why you want to retain the 𝗿𝗿 receiver, maybe you can't get to the screws underneath, or it's sort of inaccessible, you can pair the new 𝗿𝗿dige𝗳𝗲 to the 𝗿𝗿 receiver. But let me give some power on this. So the process for resetting this is turn the power off. So go from no lights, power it on, and you get the solid red light here. So you can see this alarm light here is solid red. Now, in this condition here, the override button works. So you press it and you get the override. So you can get the green light come on there. Click it again, it goes off. So you can only override a system where the link has been lost. So when this is actually paired up, the override button doesn't do anything, because if you want to call for heat, you need to do that using the thermostat. But so in this condition, we've got the override. So power it down, power it back up, get the red light on, click the override button, and also listen out for the click and make sure you get the green light, and make sure that whatever it's driving, it's actually doing what it is. So make sure that it's just that it's lost its link to the thermostat. There isn't something else gone wrong with the receiver. So click the button and you'll see, well, if it's a combi boiler, it'll fire the boiler, or if it's a zone valve, you'll be opening the zone valve or whatever. Make sure that when that green light's on, it's actually performing the function that it should. Once you're at that stage, you then need to press in both buttons together. Now, I normally press and hold in the bottom button first, and then add the second button to it. And you can see that the alarm light there is flashing, and now it's gone out. Now that it's gone out, we can let go of it. The alarm light pops back on. Then we can pop the batteries into our thermostat. Should we get them in the right way around? Thermostat will then power up, and you can see immediately as it does that, we've got the flashing red light of the alarm light to say that it's paired up. Now, because we're not calling for heat, there isn't any light on there. But if we raise the temperature up with the plus button, get the flame symbol, put that right up, you can see we've got the receiver alarm light flashing, and then the green light goes solid. And similarly, if I drop the temperature down on here, we lose the flame symbol, we get the receiver alarm, and the light goes off. So in this condition here, it's paired up, we're not calling for heat, the override button doesn't work. So just to recap that, start with the batteries out of your thermostat, power down the receiver, power it back up, press the top override button just to check that it's functioning as it should, it's doing what it should. Assuming it is, both buttons in together, number one slightly ahead of number two, press them both in together. You're waiting for the receiver alarm light to flash. Once it's stopped flashing, let go of the buttons, pop your batteries in, and you're away. It's paired up. Now, on the subject of the new 𝗿𝗿dige𝗳𝗲, let's move on to the next question, which is when I'm using the new 𝗿𝗿dige𝗳𝗲, so when they're using this one here, so this happens to be the RF902, which has got the heating and hot water. So when it's configured for both heating and hot water, how do I choose between it? on the thermostat. So first thing we'll do, power this down, and we'll power up the receiver for the RF902. Pop that one in there. Do up the screws. Now the first thing I'll take you through is the commissioning on this, because it may or it may not be, the thermostat may or may not be commissioned to it. But pop that in, do the screws up. And then when I energize that, we should get the lights come on. So there you go. That's the lights on there. So remember, the rule with these is the first thing you do before you put the batteries in the thermostat, even though the batteries are already in the thermostat here, when you get it out of the box, power this up first, then put the batteries in. Otherwise, you risk it timing out, and you'll need to go through the reset procedure. If you do need to go through the reset procedure, the way we do that is we press and hold the radiator button. So the first channel, press and hold it in, keep it held in. Let me do it with that finger there so you can see the indicators. So press it in, keep it held in. You're looking to keep it in for around about 20 seconds until you get a burst of red flashing, which we just got there. And now we're in to join mode. So you can see we've got the amber and green alternating. Once we're at that stage, we then move on to the thermostat, press and hold the calendar button, keep it held down. It then goes into scan mode. And if I get them both in shot together, after a couple of seconds, the thermostat will ask, are you trying to configure central heating? Or are we trying to control central heating and hot water? So in this case, we'll do domestic hot water and central heating. We'll save that change. You get the confirmation. And when we go back to the receiver, you can see that in this case, we've got a core for hot water, but there's no core for central heating. If we raise the temperature up, you can see that we get, as well as the dewdrop on here, we also get the flame symbol. Now we've got both channels calling for heat. Now the question was, how do we interchange between the two? So how, if we're in central heating mode, which we are, we've just raised the temperature up. How do we swap between them? Now the way you do that is you see the little radiator symbol at the bottom, on the bottom corner here. Let me bring that in as close as I can without it going out of focus. So in the bottom left-hand corner here, you've got the little radiator symbol, which means that whatever you press on the buttons here is going to be for the central heating channel. The way you change that is you press the settings button just once, and you can see that the radiator is now flashing. You now press either the plus or minus button. So you can see if I press plus and I keep pressing it, that little radiator symbol in the bottom left-hand corner is toggling between either the radiator, which is your central heating, or the tap, which is your hot water. So if we want the tap, we then confirm it. And now, if we use the plus or minus button, we are choosing whether we want the hot water on or off. And similarly, if we go into our schedules, let's get back to the home screen there. If we go into our schedules by pressing the calendar button, what we are setting up here is the schedules for the hot water, because we've got the tap in this bottom left-hand corner. We've got the little tap symbol. So again, if we want to, let's come out of that. If we want to go back and actually control, if we want to go back to the central heating setting, let's come out of our schedules, press that, and we'll come out. Come out to our normal screen. So if we want to go back to controlling the central heating, it's a quick click on the settings button. We've now got the tap symbol in the bottom left-hand corner over there flashing. We use the plus or the minus to toggle between. So change the tap symbol into a radiator symbol, confirm it, and then we are back to controlling the ambient temperature in the room. Or if we were to go into our schedules here, we'd be setting up the schedules for the central heating. So hopefully that covers that off. Right, we're racing through these now. Let's come up with the next question, which is a question about the LPs. So how do I, if I've got an archaic system that doesn't have any motorized valves, how do I need to set up the LP? So let me grab an LP. Let's go to the top down again. And we'll bring in an LP. So this is for the 2-channel LPs. So it's something like a gravity system where you've got you've got a pumped hot water system. So you've actually got a pump on the system, but there's no motorized valves or anything. So with systems like that, I mean, they're certainly not Part L compliant anymore. So you're certainly not going to be fitting any of them. But that's not to say that you can't repair them. And if you need to, retrofit to them and fit parts to them, you absolutely can do. So the way that you would tell a system like that is that if we take like an S-plan or a Y-plan system, we've got independent control between the central heating and the hot water. So that means that if we want just hot water on its own, we can have it. Or if we want just heating on its own, we can have it. So what I'll do, let me power down the back plate and I'll pop the LP onto the back plate and we'll energize it and you'll see exactly what I mean. So this is one of the benefits of having the industry standard backplate across all of our products, so that we can make the live demos certainly much easier. So let's pop that in there and power it up, and this will give us make much more sense of what I'm saying. So straight out of the box, this is what we would call in pumped mode. So you can see here, if I go in and I change the flag to off for heating, we've still got hot water turned on. I can also turn the hot water off, but then if I want to go in and just have central heating, I can have it. So we've got true independent control across both of our channels. Now, if you're running a gravity system, you can't have that, because the way it's wired is the output from the hot water, because we've not got any zone valves which are doing the flow control or firing the boiler. We need to have, you essentially have to have hot water and heating both on together. So you can't have this independent arrangement. So you can have hot water on its own. So in the summer, you're not obliged to run your heating. So the hot water output, the terminal 3 on the backplate, will go off to fire the boiler. But terminal 4, which is your central heating on, all that's doing is it's running your circulatory pump. So if we were to allow it to have independent control like this, we would just be running the circulation pump on the heating side, and we wouldn't actually be firing the boiler to send any hot water. So you'd just be circulating cold water around the system. So we need to make a change to the back of the LP. And the change is in the form of this little jumper here. So let me power it down. And you can see, if I get this in shot and it focuses, you can see we've got a slot cut out at the bottom, and there is a P. If I pull the little jumper out of the way, you can see there is a P on the left-hand side and a G. And then in that slot, you've got 3 jumper pins. Now, the default is for the jumper to be supplied like that in the P position, which is giving you your independent control between the 2 channels. Now, if you've got a gravity system, all you simply do is you pull the jumper out, and you can see all it is it's a metallic pin in there, which just shorts out either the middle pin on there to the left-hand side or the middle pin to the right. But you put it over to the right-hand side. And now, when we re-energize, you can see that if I turn the heating off, we get both channels off. So that's exactly what you expect, both of them in the off mode. If I boost the hot water or bring the hot water on, you can see that the hot water channel has fired, which is fine. But the difference is, if I choose just to have heating, it automatically brings on the hot water side, because remember, the hot water side is firing the boiler, and all the heating side is doing is running the circulatory pump. So that's how you would change over between your P and G, your pumped and gravity, by moving that little jumper pin. But they do always get supplied in the P position like that. So hopefully that answers that question. Let's have a little look and see what the next question is. Quick check in to see if we've got any questions coming in on the chat, and I don't see anything. So we're probably about halfway through this session, I would say. So you've probably got yourself another 15 minutes if you want to get any questions in to ask me. The next question is around, let's have a look here and see what they're saying. About our motorized valves. So is it possible to change just the motor in your motorized valve actuator? Well, it absolutely is. Now, you know the thing about ours, we've got these pop tops where if you don't have to drain down. So if something goes wrong, this here happens to be a 𝗳𝗍𝗃. So this is a motorized, this is a 2-port valve. This would go on typically would go on a 2-port body. You could put it on a 3-port and then it would be a diverter. But most often you will see this supplied with a 2-port 22mm body. And if it's a 28mm body, it will be a 𝗳𝗍𝗃. But they've got the little button on the side which allows you to detach them from the valve body. So if something goes wrong, if the micro switch fails or the motor fails or something goes wrong inside, you can just take these off, unwire it from the wiring center, and pop a new actuator on without the need to drain down or change out the valve body. So we've already tried to make it as easy as we can from that point of view. But if it's just that when you energize the brown wire on here, the motor is not moving over, or the valve is not moving from the A to the B position. Let me just pop that out of commissioning mode. So remember, when the valves are in the closed position, they're in the A position, and then when they're open, that little indicator there will move over to the B position, and that is as a function of energizing the brown wire with respect to neutral. So you energize the brown and you'll move it from the A to the B. So if it's not doing that, it's quite possible that you've got a motor failure. So what you can do is obviously isolate as you would normally when you're working on this sort of electrical stuff, but undo the single screw there, pop the cover off, and there you can see we've got, as well as having the sort of switching arrangement around here, which is the little micro switches where the cam hits to fire the boiler. Remember that you'll put your grey wire to a permanent live, and your orange will go off to the switch live of the boiler, and then what comes in on grey goes out on the orange when the valve is in the B position. But if it's a motor failure, then there are 2 screws down the side here. I'll do that one there, and let's see if I can do this so that it's in shot and you can see what I'm doing. So simply 2 screws, undo them, and the motor assembly lifts off. Now you have got this heat shield here, which you do need to refit, but you can see there that the motor comes out and it is on 2 crimp terminals. So you can undo those, motor comes out, all the rest of it stays in there. Whilst that's out, we can see the sort of micro switch arrangement here and how that goes together. But you can now go off and get yourself another motor. So these are synchronous motors. They're normally 5 watts. So this one here is a 5-watt synchronous motor, and then the refitting is much the same as before. So you've got this plate, this earthing plate that goes in there that sits on the top, and that's got the little hole in it where your the drive of the motor goes through that little hole there. And remember, before you put the motor in, you've got to put your heat shield on. So plate goes on, heat shield goes on, motor goes in there, do up your 2 screws, and then you can just pop your cover back on. They're non-polarity sensitive, so it doesn't matter which way around you attach them to the rail in there. But it's much easier than having to go through and change out the actuators or drain down. So another little feature, these motors readily available in your merchants, and yeah, really easy job. I'll not bore you with reassembling that, seeing as we're on a bit of a time limit, and let's move on to the next question. So quick check to see if there's anybody has said anything on the chat, and I'm not seeing anything. So probably coming down to the last 10 minutes of this now, if you do want to get any questions in. So let's move on to another question. See what we've got here. So the question is, can you talk me through the auto balancing valves? How do they work, and where do the figures come from? So quite a big question, and it's something that we'll have a look at. So let's just refresh our memory on what our auto balancing valves are. So this is a standard 15mm angled auto balancing valve supplied with the TRV4. So the whole principle of balancing, remember, is we want to try and make sure that each radiator in the system is getting sufficient flow to give its output. Now, you get a chart on the side here that tells you what you need to set the flow rate of the body to based on the output of your radiator, which in principle sounds fine. But what we've got to be careful of is this output that you get here. So, you'll go into, say, one of the merchants and buy a radiator, and it will say it's a, 1,000-watt radiator or whatever the equivalent BTU radiator value is. But that 1,000 watts or whatever the BTU is, that's going to be the output at a flow temperature. Now, a lot of the radiators that I've seen recently, the output is based on a flow rate. So 20 degrees, that's going to put us at 55, which is over the dew point of 54. So we're not going to be running the boilers very efficiently because they're not going to be condensing. Remember, to make the boiler condense, we need to keep the return temperature below 54. So 65 degrees is a much better flow temperature. 55 degrees is even better if you can go to that. But certainly, if you go at 65 degrees and you get a delta T of 20, your return temperature is going to be 45, which means you're a good 9 degrees lower than the dew point, which means your boiler will be condensing. However, at 65 degrees, your radiator, your 1,000-watt radiator that you installed, is not going to be giving you 1,000 watts anymore. So what you need to do is you need to look at the output data. Now, most radiators will give you a chart. Some of them don't always supply it with the radiator. It's something you might have to go online and look at after once you've made the purchase. But they will give you a chart which shows you the output based on the different flow temperatures. So if you're choosing 65 or 55 degree flow temperature, then you'll be able to see what the sort of derating factor is. So your 1,000-watt radiator may, for instance, become 900 watts if you're using a flow temperature of 65 degrees. So if that is the case, you'll need to set the flow rate of the auto balancing body, not at the face value of what the radiator said it was, but actually what the output is that your radiator is based on the flow temperature that you're running. So that's certainly something you need to look at. Once you've established, we didn't need that. Once you've established how much flow you need, now you can see here we give 3 options because again we don't know what you want, what differential temperature you want on your system. It may be that if you're running really low flow temperatures, you want to have a less differential between your flow and return. But if we take the example of the 65 degree radiator, highly likely that you'll want a delta T of 20. So if we take a 900 watt radiator or not a 900 watt output at a delta T of 20, we can see here that we need position 4, which is 40 liters per hour. And then you can see, if this is going to focus for me, around the top of the sort of inner nut there, you can see the different increments. So what we're essentially going to do is use our tool with the hex or an 11mm spanner on there to turn the insert to the appropriate setting. So you've got your little witness mark there, which is what you've got to align it with. So position 4, that's position 2, is position 4. So you can now see, if the camera's going to pick that up, that is set to position 4, which is 40 liters an hour, which is the requirement that you need for a 900 watt radiator. And again, like I say, that will be a function of your flow temperature. Now, your next question might be, well, what happens if I don't know the output of my radiator? So if you don't know the output of your radiator, we've put a calculator online. So if you're retrofitting these to an existing system, and it's a really good thing to do. And one of the reasons you might want to do that is dimensionally, it is exactly the same as our standard EB body. So the port sizing and the difference in size between the center line of the body and the port is exactly the same as our EB body. So it makes it really easy. You don't need to start faffing around, changing pipe sizes, or cutting bits of pipe out or adding bits in. You can swap that out with our existing body. So it's certainly something you might want to do. Now, but what happens if you don't know what the radiator output is? So you can use our auto balancing calculator. So if you Google Drayton calculator, it's one of the first things to come up. So in here, you choose your radiator size. So you can say if we've got a radiator that's 1,000 high and we'll say it's 1,200 wide, we can then pick the type of radiator. So you've got all your different types of radiator here. Let's say it's a type 22, which has got 2 panels and 2 convectors with a flow temperature of 65 degrees. You can see then that if we want to have a delta T of 20, we will be setting that at position 11, which is 110 liters per hour. And you can see here what the difference that the different flow temperature makes. So if we've got a higher flow temperature, we need greater flow through the radiator. If we've got a lower flow temperature, we need to have that water within the radiator much longer. So rather than 110 liters, so it's 65 degrees, we needed 110 liters per hour. At 55 degrees, we only need 70 liters per hour for a delta T of 20. So really useful. And the final bit I'm going to say on about that, for people that want to really get their head into the maths and understand where that all comes from, well, it essentially comes from this mass flow calculation. Now, this obviously is quite involved, but what it does do is you can sort of render it down to this equation here, which is the flow rate. And again, remember, that's the thing that we really want to get nailed down, is the amount, making sure that we get the right amount of flow into the radiator so it can achieve its heat output. We're not giving it too much flow, so it's robbing heat from the rest of the system. So it's all about getting the flow rate right. Now, the flow rate is equal to the heat output divided by this thing called specific heat capacity multiplied by the delta T. Well, specific heat capacity never changes. It's a constant. It's 4.186 joules per gram squared. Now, that normally gets approximated to 4.2 just to make the numbers easy. But the point is that 4.2 never changes. And if you're working on systems where your delta T is 20, it's that the bottom half of that equation is always going to be 4.2 multiplied by 20, which is 84. So the only thing you ever really need to remember, as long as you're constantly working on systems with a difference between the flow and return of 20 degrees, is it's your heat output divided by 84. So it'll be your heat output in kilowatts. So if it's 1,000, it'll be 1 divided by 84. And then the only other bit you have to do there is, once you've got that, you then just need to multiply it by 60 and then multiply it by 60 again, because you need to get it into liters per hour. If the first thing that you'll get is liters per second, obviously multiply that by 60, gives you liters per minute. Multiply by 60 again, it gives you liters per hour, or multiply it by 3,600. So if you want to get a bit more background on where the mass actually comes from and where what's sort of driving the calculation behind that table, it all comes from this, which is the mass flow calculation. But like I say, it all renders down to this bit here, which is your heat output divided by normally 84 if you're running differential temperatures of 20. If it's a differential temperature of 10, then it will be heat output divided by 4.2, which always stays the same, times 10. So instead of 84, it will be 42. So, but it's a useful thing to sort of remember. I normally keep it on my phone because then I can just go in and think, oh yeah, it's divided by whatever constant, either 84 or 42, depending on the type of system that I'm working on. So I think that is all there is to say on the auto balancing valve. Let's come back into the room. Just quick check in to see if there's any questions that have come in. And there is a question here about our underfloor heating controller. Let me see if I've got one to hand. I have. There's one down here. So This, the 𝗲𝗁 underfloor heating controller. And the question is, I always have trouble with connecting up and getting the pump to run. Can you just run through how I should be doing this? Okay, so let's go the top down and get rid of some of this guff and have a look at what we've got here. So underfloor heating controller. So the majority of your terminals here are going to be for your thermal actuators. So 240-volt thermal actuators need to wire in to here. Down this end is for your sensors. If you want to have a room floor sensor or a dew sensor, you can connect them up there. This contact here, remember, is your changeover. So if you apply 230 volts to this contact, you will drive the whole system into cooling mode. Not terribly prevalent in the UK, but it's worth just remembering what it's for. Then you've got your banks of thermal actuators, all fairly simple. Down this end, you've got your mains in. So this is what's actually going to come in and run the unit. You've then got your boiler interlock. Well, actually, these two terminals here, these are just a repeat of the mains in. So you'll bring a 230-volt supply into here. And then here, N3 and L3, that's just a neutral and a live supply that you can pick up from that terminal and push it around to wherever you want. Now, one of the places you might want to get yourself a live is onto B1, because this is the interlock. So normally you will have this drive the zone valve that's on the input into the manifold. So these are volt free. So you've essentially got between B1 and B2, you've got a contact, a switch that makes when there is a call for heat on any one of the zones. Now, if you don't bring anything onto B1, you won't get anything out on B2. So it's highly likely that you will put a link from the live, from L3 onto B1, and then B2 will go out, and normally it drives a zone valve. It could drive a boiler, or it could be doing anything, but it's just that if you want something to go live as a function of any one of your zones on here calling for heat, you will use the B1 and B2 connectors. Now coming on to the question that was asked about the pump. So the issue that 9 times out of 10, the issue why the pumps don't run on these systems is because what the installer does is they'll bring their pump, the feed out to their pump, the load out to their pump, and they'll wire it to the earth, the neutral, and the live. But the problem is, or the quirk of the underfloor heating controller is that these terminals here are also volt free. So you've got N1 and L1, and then you've got N2 and L2. Now your pump, rightly so, you will have wired the neutral for the pump and the live for the pump on those two there, and you'll put your earth in here. But what you also need to do is bring in another supply to go on the supply side, because again, these are volt free. So you've got a contact between L1 and L2 that will fire if there is a call for heat on any of the zones, and also that contact will hang on after the call for heat stops to give you your pump overrun. But if you don't bring a supply onto N1 and L1, you won't get anything out. So as well as having your pump connected here, you do also need to bring a supply in to so that what comes in or what's fed onto N1 and L1 goes out on N2 and L2 when there is a call for heat. So I would say of all the phone calls I've had where the pump's not running, it's because you haven't got a supply in here. Now, you can either bring a supply in, from say a wiring center, or you can come off of if you're not using B1 and B2, you can put links from N3 onto N1, L3 onto L1, and then you will have your pump connected up and go there. But remember, this is a class 2 appliance, so it may be that when you run your supply in, you're not using an earth. However, your pump will need to have an earth. I've rarely come across a pump where it doesn't require an earth. So just something to remember, and that's why we give you the opportunity to bring in a pump supply, because it may be that your thermal actuators are class 2, so there's no earthing there. You won't have any earths on your sensors. You don't necessarily need to have an earth to run the unit because it's class 2, but your pump most certainly will need to have an earth connection. Well, that sort of brings me to the end of this little session. Thanks for joining me tonight, guys. This is the last one before Christmas and the New Year. So have a lovely Christmas. I hope you get to have some time off. I'm dying to get some time off, so I'm going to have a good break, and we'll do it all again in January. But thanks for joining me. Thanks for supporting this year, and we'll get back on it on January. And again, any content that you want to see me cover off in January next year, or hopefully we'll have some new products that we can talk about and some new features. So it's good. It'll be a good 2024. But yeah, thanks for your support this year, guys, and I'll see you in the new year. Catch you soon. Cheers.